Hello everyone and welcome to Innovium Learning. This is Hemant sir, your chemistry teacher. I think this channel Innovium Learning platform needs no introduction. You all must be aware of it, and already we have uploaded some videos uh, in chemistry as well as maths. So this is yet another class of chemistry based on some advanced concepts of molality and some questions related to that molality. So without any delay, let's start today's class. So see, here it is given an aqueous solution is prepared by diluting 3.3 ml acetone of density 0.789 gram per ml with water to a final volume of 75 ml. The density of the solution is given this 0.993 gram per ml. What is the molarity, molality and mole fraction of acetone in this solution? This is the question. So see, in this question, first what we should find out? First we should find out what is the mass of that acetone. Volume of acetone is given here and the density of acetone is given. Then what is that mass of acetone? So let's find out that. So mass of acetone, that is volume of acetone multiplied with what? Volume of acetone multiplied with density of acetone. So this is coming, volume of acetone is given 3.3 multiplied with 0.789, correct? So volume multiplied with density gives you the mass. So what is that result? So if you multiply this, so what is the result? So this one will come around 2.60 approx 2.6087, correct? So this is the mass of that acetone, correct? Now you see, once you get that mass, is 2.6087, 3.3, 0.789. I think it is 2.6037. Okay, now you see, this is the mass of acetone. Next is this much gram. Now, next is that what is that mass of, what is that moles of acetone? So number of moles of acetone. Number of moles of acetone. If the mass of substance is given and molar mass is known to us, then easily we can find out the number of moles. How? Given mass of substance, given mass of substance upon molar mass of substance. So given mass, so what is that mass we obtained here for that acetone? That is 2.6037. That is 2.6037. Then what is that molar mass? In fact, acetone is this one, CS3, COCS3. This is the formula of acetone. So here in this formula, what is that molar mass of acetone? 3 carbon 36 and 6 hydrogen plus 6 42 plus oxygen is 16 plus oxygen is 16. So 42 plus 16, how much it is? 52 6. So I think this is 36, 3 carbon 36 plus 6 42, 42 plus 16, so it is coming 48 10 58. So this is your molar mass of acetone. Simply putting that value here, will get the number of moles. So this is your number of moles. So this much number of moles. Next, then what is that mass of that solution? So you see here it is given with water to a final volume of 75 ml. So this is the final volume of this is the final volume of solution, correct? Density of the solution is also given. So final volume of solution is given, density of solution is given. So easily we can calculate mass of solution. So mass of solution is volume into density multiplied with density of solution. Volume multiplied with density of solution gives you the mass of solution. Now, what is that? So volume is 75, density of solution is 0.993. 0.993. So this one gives the mass of solution. Now, what is that mass of solvent? So mass of solvent, how can we calculate? Out of mass of solution, if we subtract the mass of solute, then easily we can calculate the mass of solvent. So here on multiplying this one, you will get 74 point. Actually, this is 75 into 0.993. It is 74 point something. I think it is 74.675. Yes, yes, approx. So this is, so we'll calculate at the end so that we can save time. Okay, no issue. We'll calculate at the end. So this one. Next is, so this is the mass of solution. Next is, what is that mass of solvent? So mass of solvent is equal to mass of solution, that is 75 multiplied with 0.993 minus this is the mass of solute. So this is the mass of solution minus mass of solute. What is that mass of solute? This one, 2.6037. Correct. So this one is mass of solvent. So the mass of solvent here we are getting what? This one. So this one is mass of, so on subtracting, I think it is 71. So here it is 75 into 0.993 and this is 2.6037. On simplifying this, you will get the this much mass. So this is the mass of solvent, correct? Now, what is that molality? And what is that molarity? What is that mole fraction of acetone? Very easy. First, we will calculate that molarity. Molarity easily can be found out by applying that formula. What is that formula? Number of moles of solute. What is that number of moles of solute? That number of moles of solute is here, 2.6037 by 58. So this is 2.6037 by 58. So this is the molarity, number of moles of solute. Number of moles of solute, here it is. Number of moles of solute, here solute is acetone. Divided by, multiplied with 1000 by volume of solution in ml. So here, what is that volume of solution? Volume of solution is 75. So if we substitute that, you will get the result 2.6037 upon 58 multiplied with 1000 by volume of solution, that is 75. So simplifying this, you will get the result for molarity and the unit will be moles per liter. Unit is moles per liter. So this is the result for molarity. So you can simplify this to get the final result for molarity. Next is molality. So molality, here we can easily calculate applying that formula directly. So here I am calculating that molality. So what is that molality? Molality is number of moles of solute present in 1 kg of solvent, correct? So what is that mass of solvent? This is the mass of solvent in gram. And if the mass of solvent is given in gram, then what is that expression? That already we have discussed. Number of moles of solute multiplied with 1000 by W solvent in gram. So this is the expression for molality whenever mass of solvent is given in gram. Correct? So number of moles of solute, that is here 2.60. So that is 2.6037 upon 58. So this is 58. 58 multiplied with 1000 by mass of solvent in gram. So what is that mass of solvent in gram? That is this one, 75 into 0.993, 0.993 minus 2.6037, minus 2.6037. So 75 into 0.993, this one, minus 2.6037, minus 2.6037. This result represents the mass of solvent in gram. So on simplifying this, we can easily calculate that molality. So we got the result for molality. Then lastly, what is given? Mole fraction of acetone. Yes, mole fraction of acetone. So in the next page, we'll discuss that mole fraction of acetone. And to calculate that mole fraction of acetone, we need to know the number of moles of acetone, that is this one, and number of moles of solvent. This is the number of moles of acetone, which is number of moles of solute, because acetone is the solute, correct? And number of moles of solvent. So here it is the mass of solvent. Then from this mass of solvent, easily we can calculate the moles of solvent. How? Here I am explaining that. Okay. So you see, here only I am explaining that part is. So you see, mole fraction of acetone is equal to number of moles of acetone by number of moles of acetone plus number of moles of solvent. What is that solvent? Solvent is water. Correct? Solvent is water. So here number of moles of acetone, that is this one. This is the number of moles of acetone, 2.6037 upon 58. This is the number of moles of acetone. By number of moles of acetone, 2.6037 by 58 plus number of moles of water. What is that? This one is the mass of water. Mass of water by molar mass of water gives you the number of moles. Correct? 75 into 0.993 minus 2.6037. So this is the mass of water divided by molar mass of water. Given mass of water by molar mass of water gives you the number of moles of water. So this is the number of moles of water. This is the number of moles of acetone. Correct? So this one represents total moles. This one represents total moles of the solution. Total moles of solution, and this is the number of moles of solute. So number of moles of solute by total moles in the solution means number of moles of solute plus number of moles of solvent gives the mole fraction of solute. Here in this case, what is that solute? Solute is acetone. So on simplifying, you will get the mole fraction of acetone. So this is how we got that result for molarity, molality, as well as for mole fraction of acetone. So moving on to the next question. So here you see, this is the next question. In this question, what is asked? Calculate the mass of the solute benzene and the mass of the solvent tetrahydrofuran that should be added to prepare 1.63 kg solution, that is 1.42 molal. So the molality of the solution is given 1.42 and that mass of the solution is given 1.63. Very easy. So let's start. Just remind that basic definition always while solving the question on molality. So what is that basic definition? The basic definition of molality is number of moles of solute present in 1 kg of solvent or 1000 gram of solvent. Here, in this case, the value of molality is given 1.42 m, means 1.42 moles of solute is present in 1000 gram or 1 kg of solvent. So here 1.42 moles of solute. So what is that solute? Solute is benzene. 42 moles of benzene is present in 1000 gram of solvent. What is that solvent? Solvent is tetrahydrofuran. So 1000 gram of solvent. Correct? What is that solvent? Tetrahydrofuran. This one. In fact, what is that formula of tetrahydrofuran? This one. As formula this. Actually, this is CH2, this is CH2, this is CH2, this is CH2. So this is the formula tetrahydrofuran. So this is the solvent. Now 1.42 moles of benzene is present in 1000 gram of solvent. Now what is asked? That in 1.63 kg solution of molality 1.42, what is the mass of solute benzene and what is the mass of solvent tetrahydrofuran? First, we will consider what is that mass of this benzene, 1.42 moles of that benzene. So we know that molar mass of benzene is 78. Molar mass of benzene is 78. If we multiply this one with this, you will get the mass of that benzene, correct, which is present in 1000 gram of solvent. So mass of 1.42 moles of benzene is equal to molar mass of benzene multiplied with number of moles of benzene. Molar mass multiplied with number of moles gives that result for mass of that benzene. So what is that? That is 78 into 1.42. This much gram. Now, what is that mass of solution? You see, 1000 gram of solvent is there in which this much moles of benzene is present. Means what mass of benzene is present? Whatever mass comes for this 1.42 moles of benzene, that much mass of benzene must be there in 1000 gram of solvent, correct? Then what is the total mass of this solution containing 1000 gram of solvent and 1.42 moles of benzene? So what is the total mass? So total mass of solution. Which solution? This solution containing 1000 gram of solvent and 1.42 moles of benzene is equal to what? That is 1000. This is the mass of solvent plus what is that mass of solute present? That is this one. 1.42 moles as mass, 78 into 1.42. So this is the mass of the solution. In this much mass, what is that mass of solvent? 1000 gram is the mass of solvent. What is that mass of solute? 78 into 1.42. This is the mass of solute. Then point is here, what mass of solution is given? 1.63 kg. 1.63 kg means what mass? 1630 gram, correct? So here you see 1000. So 1000 plus 78 into 1.42 gram of solution contains what mass of solute or what mass of solvent? 1000 gram of solvent. 1000 gram of solvent. So this much gram of solution contains 1000 gram of solvent. Then 1 gram of solution contains what mass of that solvent? 1000 upon 1000 plus 78 into 1.42. So 1 gram of solution contains this much gram of solvent. Now what we have what mass of solution? So we have 1.63 kg, or we can say 1630 gram. 1630 gram. 1630 gram of solution contains what mass of that solvent? So this one is the mass of solvent present in 1 gram of solution. Then in 1630 gram of solution, what is that mass of solvent? If we multiply this one, which is present in 1 gram of solution, with 1630 gram of solution, then we'll get the mass of solvent in 1630 gram of solution. So 1630 multiplied with 1000 upon 1000 plus 78 into 1.42. So this is the mass of solvent in gram present in 1630 gram of solution. Then out of this much mass of solvent, if this is the mass of solvent, then what is that mass of solute? Very easy. Simply we subtract this much mass of solvent out of what? Out of 1630, we'll get the mass of solute, correct? So here I am calculating that mass of solute. So you see, so mass of solute is equal to mass of solution minus mass of solvent. Okay. Then here, what is that mass of? So what is that mass of solution? Mass of solution is 1630 minus mass of solvent is what? What is that mass of solvent? Mass of solvent is this one, correct? Mass of solvent is this one. So this is the mass of solvent which is present in a 1630 gram of solution. So that 1630 gram of solution contains this much mass of solvent. So this much mass of solvent we should consider here. So 1630 multiplied with 1000 upon 1000 plus 78 into 1.42. Correct? So this is the mass of solvent and this is the mass of solution. Then on simplifying, we'll get the mass of solute. So here in this question, we got the mass of solute, benzene, and that mass of solvent, tetrahydrofuran, in 1.63 kg of the solution, which is having strength 1.42 molar. I think all of you have got this answer, and this is all based on that simple concept of molality, and yes, the calculation is bit more lengthy here, but on simplifying you will get that answer. So that calculation needs practice. So it's all about that practice. If you are well acquainted with that calculation part, then easily you can simplify and we can get the answer. So next is, between 1 molar and 1 molar solution, which one is more concentrated and why? Yes, this is a very interesting and fundamental question. This question may also be asked in CBSE exam. So let's discuss. This is very interesting. Whenever we consider that same concentration of that molarity and molality for the same solution, means suppose if you consider 5 molar H2SO4 solution and 5 molar H2SO4 solution, means that same solution with molarity and same solution with molality, if we consider with the same value, means if the magnitude of that molarity and molality are same for the same solution, then which one is more concentrated? This is a very fundamental question. And always we consider that molar solution, means that solution given in molarity, that magnitude with molarity, that is always more concentrated than the magnitude given in molality for the same solution. Then here that question is based on that. Here 1 molar and 1 molar solution, so which one is more concentrated? 1 molar solution is more concentrated. Let us explain, let us discuss that concept here with a simple example. Let us consider that H2SO4 solution. Let us consider that H2SO4 solution. So if we consider that H2SO4 solution, the density of H2SO4 solution, density of H2SO4 solution, H2SO4 solution at room temperature. Here I am discussing that density at room temperature, that is 1.86 gram per ml. This is 1.86 gram per ml. Then what is that molar mass of H2SO4? Molar mass of H2SO4, mass of H2SO4, that is 98 gram, because sulfur is 32, then 4 oxygen 64, 1 oxygen 16, 440 64, and 2 hydrogen 2. So on adding, you will get the result 98 gram. So this is the molar mass of H2SO4. Now here from the density data, what we can calculate? We can calculate easily the volume occupied by 1 mole of H2SO4. Molar mass of H2SO4 is nothing but, this is the mass of 1 mole of H2SO4. So what is that volume occupied by 1 mole of H2SO4 at that room temperature? That easily we can get from this density data. How? 1.86 gram of H2SO4 occupies what volume? 1 ml, correct? Or has a volume of 1 ml. Then 98 gram will have what volume? So you see 1.86 gram of H2SO4 has a volume 1 ml. Then 1 gram will have what volume? 1 by 1.86. Then 98 gram of H2SO4 will have what volume? 98 by 1.86. This much ml. Correct? So you see 1.86 gram has a volume of 1 ml. So 1 gram, 1 by 1.86 ml. 98 gram of H2SO4 will have what volume? 98 by 1.86 ml. So on simplifying, you will get this result something around, I think it is 52 point something. Yes. So we can easily simplify that is the 52 point something. So the result is something around this 52 point something. So here this is the volume. Now here if we consider 1 molar, then if we consider 1 molar, then what does it mean? It means 1 mole solution, 1 mole solute is present in 1000 ml of solution. 1 mole of solute is present in 1000 ml of solution. So here I have considered that solution as H2SO4. You can take any solution. You can take HCl solution, you can take NaCl solution, you can take any solution, correct? But here I have taken that H2SO4 solution, correct? So here if we consider 1 molar H2SO4 and 1 molar H2SO4, which one is more concentrated? So in this case, you see that 1 molar H2SO4 means 1 mole H2SO4 is present in 1000 ml of solution. Now you see 1 mole H2SO4 has got what mass? 98 gram mass. Has got what mass? 98 gram mass. Then what volume? Volume is this one, 52 point something ml. So you can exact data, exact value you can get on simplifying this. So the volume is this one, correct, in ml. Then out of 1000 ml, if this is the volume of H2SO4, what is the volume of that solvent? Of course, here the solvent is what? Solvent is water. H2SO4 solution is given. No solvent data is given, means we can consider that as water. So what is that volume of that water? So volume of H2O, which is the solvent in that H2SO4 solution, is equal to what? Actually 1 molar means 1000 ml solution. Volume of solution is 1000 ml, correct? 1 molar means what? 1 mole solute in 1000 ml solution. So the volume of solution is 1000 ml. Out of that, if the volume of solute, here solute is what? Solute is H2SO4, and that solute H2SO4 is present by what mole? 1 mole. And 1 mole of H2SO4 has got what mass? 98 gram mass. That 98 gram mass of H2SO4 has got what volume? This much volume. So this much volume is there in 1000 ml, in 1000 ml of solution. So if we subtract that volume of that H2SO4, volume of that 1 mole H2SO4 or 98 gram of H2SO4, if we subtract that volume of 98 gram of H2SO4 out of this 1000 ml, we will get the volume of solvent H2O. So that is 1000 ml. This is the volume of solution minus volume of that H2SO4. This is 1000 minus volume of H2SO4 is this 98 by 1.86 ml. So this much in ml. Now you see this result will be definitely less than 1000. If we consider this value as 52 point something, then this result will be what? This result will be 900 something, around 947. Yes, this one will be close to 947. Correct? Or if you simplify this value, exact data, you will get that. Okay, that exact data you will get here. I have not actually calculated exactly. So the exact data you will get that. Okay, now you see. So this result will be definitely less than 1000. Definitely less than 1000 ml. Then if the volume of water is less than 1000 ml, then what will be the mass of water? Then definitely the mass of water. So the mass of H2O will be what? You know that at room temperature, density of water is 1 gram per ml. Density of water is 1 gram per ml. And if we know the volume of water, easily we can calculate the mass of water. So mass of water is volume of water with multiplied with density of water. If this is the volume of water, 1000 minus 98 by 1.86, this is the volume of water multiplied with 1, because density of water, volume multiplied with density. Density of water is 1 gram per ml at room temperature. Correct? So this is the density of water, this is the volume of water, gives you the mass of water. So this is 1000 minus 98 by 1.86. Now you see, this is the mass of water in which what amount of H2SO4 is present? 98 gram of H2SO4, or you can say 1 mole of H2SO4. So this much mass of water is there in which 1 mole H2SO4 solute is present. 1 mole H2SO4 solute is present. Now you consider this one, 1 molar solution. So 1 molar solution means what? This one means 1 mole solute in 1000 gram of solvent. So if we are considering H2SO4 here for this 1 molar solution, so 1 mole H2SO4 is present in 1000 gram of solvent. Here for 1 molar, you see 1 mole H2SO4 is present in what mass of solvent? Not 1000 gram. It is present in what mass of solvent? That solvent mass is this one. So you see same 1 mole of H2SO4 here. Correct? Here also 1 mole of H2SO4. In both cases, solute amount is same, 1 mole. But the difference lies with the amount of solvent. Here for 1 molar, that solvent amount is 1000 gram. Here for 1 molar, solvent amount is this one. and this amount of solvent, this is definitely less than 1000 gram. This is definitely less than 1000 gram. So in case of 1 molar solution, 1 mole solute, that is H2SO4 here, that is present in a solvent amount which is less than 1000 gram. So here solvent is less in amount, but here you see solvent is 1000 gram, that is more in amount. If solvent is present in more amount, then that solution is definitely more diluted. So here 1000 gram solvent means more solvent, solvent amount with the same amount of solute. And here solvent amount or solvent mass is less, solvent mass is less with the same amount of solute. So if the solvent amount is more, the solution is more diluted. If the solvent amount is less, correct, solvent amount is less with the same amount of solute, then that solution will be definitely more concentrated. So H2SO4 solution with 1 molar, 1 molar strength, that is all definitely more concentrated than the H2SO solution with 1 molar concentration, because in both cases solute amount is 1 mole, but the solvent amount here is more, here solvent amount is less, that is less than 1000 gram. So this is more concentrated, less solvent amount means more concentrated, more solvent amount means less concentrated. That means for the same amount of solute, the solute amount is same in both cases. So instead of H2SO4 you can take any other solute for that solution, correct? So I hope all of you got this concept. So through this example only we can easily get this concept clearly. That's why I took that example of H2SO4. You can take any other solute for that solution. And yes, of course, I have taken that H2O as the solvent in this case. Okay, so moving on to that next question. Find the molality of HCl solution of strength 12% W by W. Strength 12% W by W. Now see, whenever the strength is given in terms of that percentage W by W, how can you calculate that molality? Very easy. So what does it mean, percentage W by W? It means that 12 gram of solute present in 100 gram of solution. So you see, whenever that data is given for percentage W by W, what does it mean? It means a certain mass of solute is there in 100 gram of solution, correct? So if the data is given X% W by W, then that means what? If the strength is given X% W by W, suppose the strength is given X% W by W, it means X gram of solute is present in 100 gram of solution. In 100 gram of solution. So here in this case we have 12% W by W means 12 gram of solute. What is that solute? Solute is HCl here. So 12 gram of HCl is present in 100 gram of solution. Correct? Then point is, whenever the data is given in terms of percentage W by W, how can we calculate that molality? Very easy. Let us consider the strength is given X% W. So let us derive that general formula. Then we will apply this data directly in that general formula. Okay. So let the strength. So here let this one be the strength. Let the strength is equal to X% W by W. Correct? Now you see, here you see, if the solution mass is 100 gram and in which X gram of solute is present, then what is that mass of solvent? That is equal to 100 gram minus that mass of solute. So 100 gram of solution contains X gram of solute. So out of 100 gram of solution, if you subtract that mass of solute, you will get the mass of solvent. So this is the mass of solvent. Now you see, we have mass of solvent, we have mass of solute. Directly we can find out that molality applying that formula, basic formula. So what is that formula for molality? That is equal to number of moles of solute multiplied with 1000 by W solvent in gram unit. So this number of moles of solute is what? Given mass of solute by molar mass of solute multiplied with 1000 by mass of solvent in gram. What is that mass of solvent here? If the strength is given x% W by W, then what is that mass of solvent? That is 100 minus x. That is 100 minus x. And in this case, what is that mass of solute? So mass of solute here is x, correct? So that also we can put here. So you see, this is x. This is the mass of solute. Mass of solute by molar mass of solute. This one gives that number of moles of solute multiplied with 1000 by mass of solvent 100 minus x. Now directly we can put that data given. Now for in this question, what is that x value? If the percentage strength is given x% W by W, then the expression to find out molality is this one. Then the expression to find out molality is this one. But in this case, we have that strength given 12% W by W. 12% W by W. So the x value here is what? 12. So in this question, we have that x is what? That x is 12. So if we put that value of x12, then we'll get the result of molality, that is 12 by molar mass of solute. Molar mass of HCl is 36.5 multiplied with 1000 by 100 minus 12. 100 minus 12 because x is 12. So simplifying this, we can easily calculate that molality, and its unit is moles per kg. Okay, so this is how we can calculate that molality if the data is given for that strength in terms of W by W, or we can say this is your strength in terms of percentage by mass. That percentage W by W is also known as percentage by mass. Okay, I hope all of you got this approach to find the solution of this question. So moving on to the next question, find the molality of H2 super solution of strength 10% W by V and density 1.2 gram per ml. Yes. So here the strength is given in terms of W by V. So what do you mean by that percentage W by V? It means a certain mass of solute is present in 100 ml of solution. In 100 ml of solution. So this V is the volume of solution. This is the mass of solute. So if let the strength equal to x% W by V. So first we'll derive that general formula, then we'll apply the given data in this question in that formula, so that easily we can get the result. Okay, so you see x% W by V. So this is equal to x gram of solute in 100 ml of solution. So if we take 100 ml of that solution, in that 100 ml of solution, mass of solute present is x gram. Now here density of the solution is given 1.2 gram per ml. So if the density is 1.2 gram per ml, then what is that mass of 100 ml of solution? You know that mass of solution. Why we are calculating mass of solution? Because you see, to find out that molality, always we need to know the mass of solvent in which that solute is present. Correct? Because in the formula of molality, there we consider number of moles of solute present in 1 kg of solvent or 1000 gram of solvent. So always we should know we need to know the mass of solvent which is present in that solution, so that we can easily find out that molality from that basic formula of molality. So mass of solution for that 100 ml, mass of solution of 100 ml, mass of that 100 ml solution, 100 ml of solution. Why 100 ml? Because I have taken 100 ml of solution in which x gram of solute is present, is equal to what? Volume into density, because density is given. So volume is 100 density is 1.2. So this is coming 120 gram. So 120 gram is the mass of solution, uh, and the mass of solute is x gram. So what is that mass of solvent? So mass of solvent in that 100 ml solution, what is that? In 100 ml solution, what is that mass of solvent? So what is that mass of solution of 100 ml volume? That is 120. So this is the mass of solution, out of which if you subtract that mass of solute is what? X. So here, here actually density, this is the general formula. So if we are considering general formula, so we can take the density as d gram per ml. Yes. So here you see, actually here we are deriving the general formula. So for general formula, we can take the density as d gram per ml. So here it will be 100 d, this much gram. So what is the d? D is nothing but the density of the solution in gram per ml that we have considered here, correct? So here I am mentioning that, where d is the density in gram per ml, density in gram per ml of the solution. Okay, so here if the density of the solution is d gram per ml, then volume of solution is 100, then what is that mass of solution? Mass of solution is 1 volume multiplied with density, that is 100d. So 100d is the mass of solution, out of which we will have to subtract that mass of solute, that is x gram. So here this is the mass of solution. Mass of solution is 100d, out of which we are subtracting that mass of solute, that is x gram. So we are getting the mass of solvent. So this is the mass of solvent, correct, present in 100 ml of solution, and the mass of solute present in that 100 ml solution is x gram. Then what is that molality? Then go directly to that formula, basic formula of that molality. So that basic formula of molality, that is equal to number of moles of solute multiplied with 1000 by mass of solvent in gram. Next, the number of moles of solute, that is W solute by molar mass of solute multiplied with 1000 by W solvent in gram. So what is that mass of solvent in gram? That is 100d minus x. Then what is this mass of solute? Mass of solute is x, that we can put here, correct, that we can put here. So this is the general formula to find out the molality if the strength of the solution is given in terms of percentage W by V and density data is given for that solution. So here in this case, that x value is nothing but 10, because the strength is given 10% W by V, and also we have derived that general formula taking that strength as x% W by V. So this 10 is nothing but x, and density D is given 1.2. So now we can use that data directly. So x is 10 divided by molar mass of solute. Solute is H2SO4, that molar mass is 98 multiplied with 1000 by 100 into D. Density is 1.2. Density is 1.2. 1.2 minus that x value is 10. So on simplifying, we will get the result for molality. So and the unit is what? Unit is moles per kg. So I hope all of you got the concept what I explained here to calculate the molality if the percentage data given in terms of W by V and density, correct? Next, I hope all the questions are done. Okay, so this much is for today's class, and I hope all of you got the concepts what I explained in today's lecture. Today I explained three concepts. One is that how to calculate the molality if the percentage by mass data is given. Then how to calculate that molality if the percentage W by V data is given along with density. And also we calculated molality using mole fraction. Yes, one more interesting thing. Let me explain you that general expression to find out molality if the mole fraction data is given. Okay, so let us discuss that. So you see, so that directly you can calculate. Yes, so you see, if the mole fraction of solution, if the mole fraction of solute and solvent, if the mole fraction of solute is given, mole fraction of solute that can be written as what? This one, chi solute, that is given as A. So mole fraction of solute is given as A, and mole fraction of solvent will be what? That is 1 minus mole fraction of solute, because you know that sum of mole fraction of solute and solvent together, that will be equal to 1. So if the mole fraction of solute is known to us, then how can we calculate that mole fraction of solvent? 1 minus mole fraction of solute, correct? Because we know that mole fraction of solute plus mole fraction of solvent for any solution, that is always equal to 1. So the mole fraction of solvent is 1 minus this. So this is equal to 1 minus A here, because we have taken that mole fraction of solute as A. Now the question is, if this much data is given or only mole fraction of solute data is given, how can we find out that molality? Very easy. Go to that basic formula, basic definition of molality. What is that basic definition? Basic definition is number of moles of solute present in 1000 gram or 1 kg of solvent. 1000 gram or 1 kg of solvent. Now here, what is that moles of solute? If that mole fraction data is given, what does it mean? It means it means that a mole, if the mole fraction of solute is given A, it means a mole of solute is there out of 1 mole of solution. Because you see, if we consider that suppose let me explain you through an example. Suppose in a solution of ethanol, mole fraction of ethanol is given 0.2. Then what does it mean? It means that mole fraction here, it is water, solvent is water. In ethanol, aqueous solution of ethanol, if the mole fraction of ethanol is 0.2, then what is that mole fraction of water? Very easy, 1 minus this 0.2, 0.8, means total moles of solution is 1 mole. Out of 1 mole of solution, that moles of ethanol solute is 0.2 mole. So here you see, if the data for solute mole fraction of solute data is given, then what does it mean? If you take 1 mole of solution, then out of that, solute mole is nothing but that mole fraction of solute, and solvent mole is what? Simply 1 minus that mole fraction of solute gives you the solvent moles in that 1 mole of solution. So you see, so here if we consider number of moles of solution here number of moles of ethanol solution, if we take 1, number of moles, total number of moles of ethanol solution, if we take 1, out of 1 mole of this ethanol solution, ethanol number of moles is, this is the number of moles of ethanol, which is 0.2 mole. Then what is that number of moles of that water? That is 0.8. So this is the number of moles of water. So always that mole fraction data gives us idea about the number of moles of solute or solvent out of 1 mole of the mixture or out of 1 mole of that solution. So here mole fraction data. So here the mole fraction data of solute, if we are considering A, that means if we take 1 mole of that solution, out of that 1 mole of solution, what is that number of moles of solute? That is A. Then what is that number of moles of solvent? That is 1 minus A. This is the concept. If you know this much concept, easily you can find out that molality. Now let's go to that basic expression of molality, basic formula of molality. So I hope for this much all of you have got this concept here. So you see, if the total moles of solution equal to 1 mole, then number of moles of solute will be nothing but A, and number of moles of solvent, that is 1 minus A. Now very easy, by using the basic formula of molality, we can calculate molality, we can get the result for molality. So what is that basic formula? Number of moles of solute. What is that number of moles of solute here? That is A. Then number of moles of solute multiplied with 1000 by mass of solvent. So this is W of solvent. Now this is A multiplied with 1000. So what is that mass of solvent? You see, the moles of solvent is known to us. If the moles of solvent is known to us, easily we can calculate the mass of solvent, because molar mass multiplied with moles, molar mass multiplied with moles gives you the mass of the solvent. So here molar mass of solvent multiplied with number of moles of solvent gives us the mass of solvent. So this is equal to A multiplied with 1000 divided by molar mass of solvent, correct? Molar mass of solvent multiplied with, what is that number of moles of solvent? That is 1 minus A. That is 1 minus A. So finally we are getting that expression of molality using mole fraction, that is A divided by 1 minus A multiplied with 1000 by molar mass of solvent, correct? So A is nothing but what? Mole fraction of solute divided by 1 minus A gives that mole fraction of solvent multiplied with 1000 by molar mass of solvent gives you the molality. So whenever mole fraction data is given for solute or solvent, whatever, correct, easily we can calculate the molality of the solution, correct? Suppose a question is given that mole fraction, suppose one example here, I am explaining through an example. If mole fraction of HCl solution is given 0.2, if there is an HCl solution of mole fraction of HCl 0.2, then what is its molality? What is its molality? Very easy. So molality is equal to mole fraction of HCl is given 0.2, then that is the solute mole fraction, HCl is the solute. Then what is that solvent? Solvent, obvious, that solvent is H2O. And what is its mole fraction? That is 0.8, because mole fraction of solute plus solvent is 1. So this is given 0.2. Then mole fraction of solvent is 1 minus 0.2, that is 0.8. So this is 0.8 multiplied with 1000. What is that molar mass of solvent? Solvent is nothing but H2O here. That molar mass is 18. So simplifying this, easily you can get the result for molality. So this is another important expression to find out molality. So today we discussed 4 different concepts, 4 important concepts. One, to find out molality if the percentage by mass data is given. Second one is if the percentage W by V data is given along with density, how to find out molality, that also we discussed. Third one is this, if the mole fraction data for solute or for solvent, if the mole fraction data is given, easily we can find out molality using this expression. This is the third one. The fourth one is very fundamental question usually asked in CBSE. Out of 1 molar and 1 molar solution, which one is more concentrated? Which one is more concentrated? So that question may be asked 2 molar, 2 molar, 5 molar, 5 molar, correct? Any magnitude of that molar concentration, any magnitude of that molar concentration, and that same magnitude of that molar concentration, correct? That may be asked for the comparison, correct? So I hope all of you got all the concepts what I explained in today's lecture, and you must have enjoyed the concepts what I explained in detail. And good news, students, those who are preparing for JEE Main Session 2 and Neet, very soon we are going to upload a series of videos on P-Block. This is on demand of students because very soon that board exams are going to be over, and after that their preparation will become more fast, and this P-Block videos will facilitate their preparation. And test series for that JEE Main Session 2 as well as Neet, that is also available in our website. So if you are a new students to this channel, you do subscribe and share among your friends